Okay, so chapter 5 was going, I think, right?
Yes, sir.
Yes, sir.
Okay. So actually, I will start from chapter 5 only. So this may be the revision class. So I may be teaching the thing you might have gone through, but I will start from chapter 5 only. So from the beginning, I will teach, and then I will continue in the further classes. Okay. So for that, let me share screen. Okay. So, you are also B.Tech first year. I mean second semester people.
Yes, sir.
Yes, sir.
Okay. So 9th June. Okay, then let's start. So from the beginning, I will start. So this may be revision for someone who already know the things. I mean, who have attended this. So, so I think coloring of graph was going right.
Yes, sir.
Yes, sir.
So the topic is okay. So we may okay. Let me discuss some basic things. So check whether you. So can you tell me anyone what is a graph? So let us discuss few basic things. So you may consider this a revision class. So don't worry. Okay, so any one of you unmute and tell me the definition of graph. So what is graph? You can tell me in your language. If you tell the wrong answer, then I don't mind. Okay, you can tell. You are free to
Collection
answer.
of vertices and edges.
Okay, yes, collection of vertices and edges. Fine. Yes, so it is a collection of vertices and edges.
Graphical representation of objects and the connections that live between them.
Yes, that is also fine. So let us today discuss only basic things. Then we'll continue in the next class. Okay. So okay, so in the book language, like the book you follow, I think it is some DB West, right? The author is Introductory Graph Theory, Introduction to Graph Theory. So if you write the definition of graph in terms of that book, you are already familiar, I think. So, so the book writes like the a graph is a triplet or a triple consisting of consisting of a vertex set. So you denote it by V of G means vertex set of graph G, and edge set that you denoted by E of G, edge set of G, and a relation between a relation that associates uh, two vertices, or you can say that associate each edge and vertices, like edges and vertices, you can say like this. or edges between two vertices, you can say like this. So this is the definition in the book, if you see, but you also told correct definition. So we can make one graph like suppose a, or you can say x, y, z, w. These are four vertices. This is edge xy. There is an edge from y to y. So that start with y and end at y, and you may join like y to w. Okay, or if you can join x to z, or maybe x to w, or another edge from x to w. So this is a graph, fine. So how many vertices it has? So it has four vertices, right? So if you write, it has four vertices. So let me call it graph G. So graph G. So like vertices are x, y, z. Or do you directly, let me write this, V of G. So vertex set x, y, z, w, right? And edge set. So how many edges it has? So
Six.
it has four vertices and yes, everyone. Are you sure?
Six edges.
Yes. So you are right. Six edges. So how would you name it? Like you can say XW, WX. Yes. Or X. Then XY, YY. Then XZ.
XZ.
Yeah. Then YW. I think that's all. Okay. So this graph
Yes.
has four vertices and six edges. Okay. So do you know what is a loop?
Yes.
Yes. So what is the definition of a loop?
Pairs whose endpoints are equal.
Yes, correct. So an edge whose endpoints are equal. Good thing at least you remember you all. So just I'm just checking that you remember or not. So I'm happy that you all know. So a loop is an edge whose endpoints are equal. You can see in the last graph, we had one loop, right? This y. So it started at y and ended at y. This was a loop. Okay. Then, so for example, like if I have two vertex like this, so may have like this. Sorry, hmm, this type of thing. Okay, you may be making graph like this. So this is a loop like this. Okay, so what is multiple edge?
Matches with same pair of endpoints.
Yes.
Yes. So name itself suggests the definition multiple edge. So edges having same pair of endpoints. Like there are more than one edges between two endpoints. So edges having same pair of endpoints. Okay, so for example, like for four vertices of, so this is a multiple edge. You can see like here we can also make like this. So there are two multiple edges. So x y we have two edges between x and y, two edges between y and z. Okay, so what is simple graph? How you define simple graph?
Graph without multiple edges and loops.
Yeah, correct. So a graph without loops or multiple edges, correct. So it is a graph without loop or multiple edges. So for example, if you make, so is it a simple graph what I made, like x y z w? Yes or no?
Yes, sir.
Yes, so this is a
Yes, sir.
simple graph, right? So if you take any loop or if you make any multiple edge, then it will not be a simple graph. Okay, so now, okay, so if I make a graph, suppose 1 2 3 4 5. Okay, so like x y z w, or let me say u. Okay, so which vertex is the adjacent vertex of x?
Jet.
Z. Okay, adjacent vertex of u,
Also,
no
multiple
vertex,
edges.
right? Okay, so you know the definition of word, hai na? So adjacent means, so how we define adjacent vertices? So if I like to define adjacent vertices, so how will we defining adjacent vertices or vertex, you can say? So how do you define adjacent vertex? You can say in your own word.
Sir, if an edge exists between two vertices, then it's an adjacent vertex.
Yes, so like two vertices are adjacent if it is the endpoint of a of an edge, right? So yes, correct. So simple, if two vertices are endpoints endpoints of an edge, then they are adjacent. Fine, yeah. So if two vertices are endpoints of an edge, then that two vertices will be adjacent to each other. Or you can say also adjacent vertices are neighbors. So you can say they are neighbors, like okay, they are neighbors. Okay. Now the word comes. What is a finite graph? So in the graph, last graph, what I made, you can say x is adjacent to z, y is adjacent to w. There is no adjacent vertex of u because u has no edge with other vertex. Okay. What is finite graph? So name itself says the definition.
After certain assets are finite.
Yes, simple, like it has finite number of vertices and edges. So obviously in the course, in this course, we'll consider only finite graph. Like we'll not consider any graph which has infinite vertices or infinite edges. So just for knowledge, so finite graph is what? A graph consists of or containing. So like you can say a graph is finite if its vertex set and edge set. So vertex set, V of G, and edge set, E of G, these are finite set. Okay. So if vertex set and edge set both are finite set, or number of vertices and number of edges are finite, then we call it finite graph. So in whole courses we'll consider only finite graph. We'll not consider any infinite graph. Okay, there is also word comes like null graph. So this type of, actually this null graph will not come in the course. Just for introduction I'm telling. So if you come across this word, so name itself again saying null graph means,
No vertex set.
yes, no vertex set. So vertex set is empty, right? So if your vertex set is empty, so again this type of situation will not consider in this case. I mean in the course. So will not consider any graph that is null graph. So this will make create confusion or ambiguity. So we will not consider any cases like this null graph. Okay. So you may not be like imagine any graph without any vertex. Okay. So we'll not consider this type of graph in this course. Okay, so like the complement set. So similar to complement set, we have complement graph. So complement graph. So how we define complement graph? So suppose I say this is vertex x, y, z, and this. So what will be the complement graph of this? This is graph G. Let's say this is
As
graph
it is
G.
exact.
Yes. So x, y, z. So x, y, z. These are three vertices. So I would like to know about graph G complement. Okay. So in this case, complement means like x,
X,
y.
Z, and
Yes, x, y edge exists in G. So you will not take any edge between x, y. And we considered about the simple. I think complement graph of only simple graph will consider. So like x, z you join, and you can join yz. This is a complement. So xy was there in G, so it will not be the edge in G complement. Okay, so we can define it like, if you like to define, so the complement graph G, let's say G complement we define. So complement graph G complement of a simple graph, G is, so complement, if G is a simple graph, so complement graph will also be a simple graph. So this is a simple graph such that we can say simple graph with vertex set, you can say V of G complement. So vertex set of G complement I'm talking. Okay, defined by defined by so simple. If suppose you say UV is an A in G complement. Okay, then UV will not be the
Okay.
edge in G. Fine. Yeah. So if UV is an edge in G complement, then UV will not be the edge in G complement. G. You can reverse the definition. This is mainly the definition. If UV is edge in G complement, then UV will not be the edge in G. Or opposite, like UV is edge in G, then UV will not be the edge in G complement. Okay. So next the word, like this was the example. You can make more example. So suppose I make 1, 2, 3, 4. Suppose so this and this I make. So its complement will be, so name you can say XYZW. Okay, so XYZW. So XY has already in G, so this is a graph G, and I'm talking about graph G complement. So YZ will be one edge, ZW will be other edge, and WX will be one edge. Okay, this is fine. Can we
Yes.
say this is G complement? Yes. So XY was there, you cannot join. W, Y, and X there was already, so you will not join. This is a complement graph. Okay. So next word it comes clique. CLIQUE. So what is the definition of clique?
Pairwise adjacent vertices in a graph.
Yes. So clique is a set actually. So this is a set of pairwise adjacent vertices, right? So a clique in a graph G is set of, this is a set, so collection or collection of set of pairwise pairwise adjacent vertices. Okay, so for example, let me make 1 2 3 4 5. Okay, so join this this. Okay, and let's join this. So X Y Z W U. Okay, so which set will we click for this graph?
UXW.
UXW.
Yes, UXW is one. Any other?
UX.
Like you can make pairwise then. UXW is fine. Like you can make XY, you can make YZ, right? WZ. So adjacent vertices, right? Pairwise adjacent vertices. So if you write a set in which all should be like here, each other, any two you take that will be adjacent to each other. So there will be a vertex edge between these two vertex. Sorry, U, and this was UXW. Okay. What if I take the complement? So this was the graph G. Let's make the complement of this. So complement means one vertex, two, three, four, five. Okay. So complement will make. So only you can join X, Y, Z, W, U. You can join WY, you can join UY, yes,
XZ.
XZ, correct, XZ, yes. Any more?
UZ.
UZ, yes, UZ. Okay, so UY, UZ, WY. Okay, I think that is fine, right? So can we join more? So that is a complement. Okay. Now can you? This is a graph G complement. This is a graph G complement corresponding to that G. So tell me the click in this case.
UI.
So only any click can you write of size 3? Will there be any click of size 3 in the G complement?
No, sir.
No. So only two you can make. Like you can write XZ, okay, ZU, like this, WY, this pairwise. I mean, of size 2 you can write. Click of size 2 you can write. Okay. So next word is independent set. or you can say stable set. So what is definition of independent set? This is just opposite of click, I think.
Set of pairwise non-adjacent vertices.
Yes. So it is the set of pairwise non-adjacent vertices. So actually the click was the set of pairwise adjacent vertices. So this is pairwise non-adjacent. So you can write it. It is the set of. It is the set of. It is a set of pairwise non-adjacent vertices. It is a set of pairwise non-adjacent vertices. Okay, so in the graph G, what would be the independent set?
UZ, UY,
U, Z, U, Y, yes. So can you write
XZ.
any independent set of size 3 in the graph G?
No, sir.
No. Okay, so like in graph G, so independent set would be like U, Z, no? U, Y, like this. No? Okay, so this is graph G. Okay, in graph G complement, what will be the independent set? Can write any?
UX,
Ux. So UWX if you write, is it fine? UWX. So UX has no edge, UW has no edge, WX has no edge. So UWX you can write, isn't it?
yes.
UWX, they are pairwise non-adjacent. So UWX, or you can write others like UWX, and you can write YZW also. YZW. No, no, sorry. So YW has edge. So non-adjacent you want to write, okay? Mm.
YXW.
YXW. But YW has edge. No, non-adjacent you want. Okay, so you cannot write anything other. Okay, so what I would like to say, see, XUW in case of G. In case of G, if you see, so XWU was the set, XWU, this was the click. And then that set in case of G complement is an independent set, right? So do you know the result? What is the relation between independent set and click? Do you know? In case of G and G complement, are you getting what I want to convey? So X, Y, Z, W, and U. Again X, Y, Z, W. I'm making again, okay? So what I want to say you, this is a graph G, and this is a graph G complement. So do you know the result? See, X, U, W. In case of G, look at X, U, G. In case this is what
Please.
is a click, right? And X, U, W. In case of G complement is what?
Independence.
This is independent set. Again, like you write some other click here, or can you write independent set in G? So independent set in G, like UY, you write. This is independent set in G. So UY in case of G complement will be what? There is na UY or age, they form an age between U and Y. So that will be click.
Yes.
So what I like to convey? In case of G, the click becomes independent set in case of G complement, and vice versa. Independent set in G becomes a click in the G complement. So like this, you can write result it is, or you can say the theorem. So simple. So click in G is independent set in G complement. Okay, right? Or other way you can write. So independent set in G is click in G complement. So you know already. I think you all know already. This thing. Okay. So let me write one question and see whether you answer or not. So question is, I'm writing a statement. You have to tell me true or false. So like if I write every five vertex graph, means graph of five vertex, has a click of size 3 or independent set or an independent set of size 3. So this statement is true or false. You have only two options, true or false. So false means one example is enough. Like if you write one graph that has neither of click or independent of size 3, that's fine. If you true, then you have to check for all the cases. I mean, you have to prove. So tell me true or false.
Sir, false.
False. Why?
So true.
Sir, in C5 case, this is not perfect, sir. Not
Okay.
matching the
Yes.
statements.
Yes. Yes. So, 1 minute. So the C5 case. Okay. In this, you can see. So, is it has click of size 3 or independent set of size 3? Yes. This is example. So, answer is this is
So
false.
independent bit of size 3.
Tell me.
Sir,
Suppose
independent set it has, but it has no click of size 3.
independent. Tell me independent set of size 3. Tell me the set.
XWZ.
XWZ.
X, W, Z. So XW has an age. So how we can say independent? Independent means they are pairwise non-adjacent. Means
So you
any
write W two times.
no, no, XWZ. Oh, sorry. 1 minute, 1 minute. So XYZWU. Okay, no problem. I write U. Now you tell. Now you tell the
Yes,
set.
sir, XWZ.
X
X W
W.
Z is
So what do you want to say? This is independent set. So what is definition of independent set?
yes.
Pairwise non-adjacent. So do you think WZ are non-adjacent?
Yes, I said just
Yes, sir.
So this is wrong, right? Because WZ are adjacent to each other because there is an edge between them. So if there is edge, then they are adjacent. So you will not be able to find the independent set of size 3, neither clique of size 3. So this graph has 5 vertex, but it has neither clique of size 3 nor the independent set of size 3. The answer will be false. This statement is false. Okay. In place of 5, if I write 6, then the same statement if I write, and in place of 5, I write 6. So what did you tell? 1 minute. Okay. So I pasted it. Open paste. Yeah. So now I want to say in place of 5, let me remove this. In place of 5, I have a 6. Okay. And then I would like to ask you, yes, true or false.
some false.
Okay. Give me one example.
No, sir, true.
So like you
So
want
in case of C6, we have independent set of 3, sir, but
1 minute.
there
Uh,
is no click.
no, either of them we need. Either click or. This is not and. In the definition, we have written or. So or means either
Yes,
click
sir.
or independent set. One of them or
Okay,
both,
okay, okay, sir.
right? Like X, Y,
Then
Z,
true, sir.
U, V. So you make any graph of 6 vertex. So in that case, either you will get 3 vertex of click of size 3 or independent set of size 3. So in this case, if you see, you have you can write X, Z, and U. This is independent set. Or other set you can also make like Y, W, V. That is also independent of size 3. The matter is we were looking for size 3 is also independent set of size 3. Okay. And if you don't join someone, then other case you can also consider, like if you consider this, then in this case you will have click of size 3 if you join UX, then or if you join any other, then still you will get a click. So either click or independent set you will get always. If you join, then you will get if you join more, then you will get clicks. If you don't join, then you will get independent set. So this statement is true. You can prove it. And okay, so now what is the definition of bipartite graph? Because this word will come in chapter 5 also, k partite graph. I mean coloring of graph. So we'll see there k partite graph or k colorable graph. So name itself says bipartite graph. No one knows? No, I think you all know. Don't want to
Sir,
tell? Yes?
sir, if there is a set X and Y,
Hmm.
then every vertex of set is connected with each vertex of set Y.
Okay, but bipartite. Okay, so you want to say two sets are there. So every vertex in the first set will be connected to other set. I mean, you want to say this?
But no vertices of same set can be connected to each other.
Yes, sir.
Okay. Okay. Yes. Yes. So you are trying, I think, correct thing. So if no vertex in a set connected to each other, that is independent set. Because they will be pairwise, non-adjacent. I mean, so that is independent set. So you can say vertex set can be written as union of two independent set. So your answer is correct. So in a language, if I write right, so a graph is a bipartite graph. Means you can break into two parts like this. Bi means two, part means two parts in mathematical sense. So a graph is bipartite graph if vertex set of G can be written as, or this is the union of two disjoint independent set. Disjoint means they have nothing common. So for example, let's see C6. Like, look at this graph. So I would like to say this has six vertices. Okay, x, y, z, w, u, v. Okay, so vertex set of this graph, you already know vertex set of this graph. I'm saying x, y, z, w, u, v. This is a vertex set, and vertex set can be written as, so do you know the collection of independent set? Like you can write x, z, u. This is independent set, and other independent set is YWV. Fine. This is one independent set, this is other independent set. You take union of both, you'll get this.
Yes, sir.
So vertex set you can write like X, Z, U union YWV. So this graph is bipartite graph because vertex set you can write the union of two sets and both are disjoint, and disjoint means nothing common. You know the disjoint which they have nothing common. Intersection is 5 and they have nothing common, and each part these two set are independent set, means there will be non-adjacent vertices in one set. Okay, so in the basis of this, like one more you can define. Suppose we have 1 2 3 4 and 5 6 7 8. So suppose we have eight vertices x, y, z, w, and let's call a, b, c, d. So there are eight vertices, so you join like join this, you join this, then you can join this to this. This one, and now okay, so in the graph you have eight vertices, right? So vertex set of G has x, y, z, w, and a, b, c, d. These are vertex set. So can you say me what are the independent sets in the graph? You can make like, can we say x, y, z, w, this is independent set?
Yes, sir.
Because all are non-adjacent to each other, because there is no vertex between any two of them. And again you have other a, b, c, d. Again these four are non-adjacent because there is no edge between any two of them. The rest you can make, like you can make one with edge, no problem. So so finally you can write it like x, y, z, w union a, b, c, d. So vertex set of G is the union of two disjoint set, and both sets are independent set. So again, this is the bipartite graph. Fine. So you can extend this definition to the k-partite graph. So k-partite graph. So now can you define this on the basis of bipartite? Yes, you can generalize this definition. So you read this definition of bipartite means two parts. You are breaking the vertex set into two parts. Means two sets, two independent sets. Okay. So vertex set is a union of two independent sets. So in k-partite graph, what you how will you define? Just
K
extend.
independent set.
Yes, k independent. Like you can write k a graph in which, so like a graph G is k-partite graph if vertex set of G can be expressed as union of k independent set. Union of k independent set. Okay, like this. So you can think of some example like three partite graph. So union of three independent sets. If you can write like this. Okay. Then do you know the chromatic number? Because this will be needed in the chapter coloring of graph. Okay. So what is the definition of chromatic number? Notation is chromatic number like chi of G. This is the notation.
So the least number of colors that can be used for a graph. I mean, to color a graph.
Right, when two vertices with an edge have the different color. This is the condition, right? So an edge will have the different color on the endpoints. This is the condition. So minimum number of colors you need to level the graph so that any two endpoints of any edge will have the different color. So if I write the definition, so it is like, so the chromatic number of a graph G is denoted by, so we denote it by chi of G and defined by, and we define it by, so we define by that it is the minimum number. So you can say like it is the minimum number, it is the minimum number of colors, it is the minimum number of colors needed to level the vertices of a graph. Okay, it is a minimum number of colors needed to level the vertices of a graph so that adjacent vertices adjacent vertices adjacent vertices receive different color. Okay, So again, read the definition. It is a minimum number of colors needed to level the vertices. Color, you can say like label. So like two edges will have two vertices of an edge will have the different color. So for example, if I ask you, so C5, so what is the chromatic number for this graph C5? So this is one, second edge, first, the third vertex, fourth vertex, fifth. There are five vertices. So if you color it with the different colors, so how many colors you need, so that at least minimum how many colors you need, so that any two adjacent vertex will have different color. So what is yes. So you can think of like, suppose I start with the red
Three,
color.
sir.
This is the red, okay? Yes, yes. So next I can think of, suppose I change the color. So I change the color like a black I took here. So you take other color, or let me name it directly. One first color you take here, simply. Here you cannot take the first color, you have to take the second color. Now you can take here first color, no problem, because we want to minimize the number of colors. So on the third here you cannot take one, so you can take two. Now here neither one you can take, because here is already one edge with the color one, and here you cannot take two because you already have an edge with the color two. So the condition is every adjacent vertices will receive different color, right? I mean, so you have to take the third color here. So minimum colors required is three. Fine. Okay. What about C6?
Two. Two.
Yes, you can think of like one, we take here two, we can take here one, we can take here two, then again we can take here one, and we can take here two. So only two color is enough. So chromatic number and here of this graph is two. Okay. So this was just basic thing. You might have learned it very in the very beginning. Okay. So like one result I would like to write, then we'll finish, and then we'll continue in the next class. I will continue with the coloring of the graph. So this was the basic idea. So I may need it in that. So and since I was starting it, so I just start with the basic, and then in next class I will start with the coloring of graph. So one remark I would like to write. So remark is a graph is k-partite, means vertex set will be union of k independent sets if and only if chromatic number is at most k, at most k, ज़्यादा k होगा. Like you can think of C6. You remember for the C6, it was a bipartite graph, मतलब two partite, you can say two partite graph. So it has the color you require at most two. Chromatic number is at most two, and you get here two, right? Two or less than two, so that's two. Again, if you write C5, so it is not bipartite, it's a tripartite. If you write, okay. So I think we should stop here today, and we'll continue in the next class from coloring of graph. So anyone has any question? Do you want to ask anyone question? Anyone has any question you would like to ask to me? Then no question. Then we can finish our. It's a nice meeting you all, and it's a good thing that you answered question, right? So in online, it is rare to see many
Thank you, sir.
people answers
Thank you,
question.
sir.
Yeah, I'm very happy. Thank you so much,
Thank you,
everyone.
sir.
We'll meet in the next class. Thank you.
Thank you.
Thank you so much.
Thank you,
Thank you
sir.
so much, sir.
Thank you, sir.
Yeah, thank you, everyone.